RP people on yeah, I've joined some people who do role playing and that's fun.
Like
They're
like
interesting.
like LARPing or like on a server?
Like on a server.
Okay, so what kind of RP? Like,
Uh
is it like in the context of something?
I mean, I don't really know yet because I haven't been part of like a lore thing yet. I'm
Oh.
talking to what is basically the DM about what I want to do for it. And I also was like, yeah, you can just do what you want to with my character. I don't really know where I want to go with them. So I basically was like, okay, I'm giving you the wheel. You're gonna get to describe this. I don't know what's gonna go on, but you do, and that terrifies me, but it's gonna be fun.
Okay, okay. I'm thinking I'm getting the vibe. I think I'm getting the vibe. Um, that is very fun. There's so one of the parks near my house, they always had a bunch of like people who were LARPing.
Hmm.
Ah, it looks so much fun. It looked like somebody, they guys had a huge squad. They had like 20, 30 people, like all like dressed up and stuff. And I'm
Hmm.
like, that looks like so much fun. I'm so down for that. I think the closest I ever did, the closest thing I ever done to that was when I made a video from one of my history classes in high school. It was like it was based on the U.S. history, but we did
Hmm.
it in like the context of Star Wars Episode 3. So like
Hmm.
Andrew Jackson was like Anakin Skywalker or something, and then so we went out and we got like the clone trooper masks, and then we went out and we like filmed like a video of like this really crappy parody of Episode 3. It was so funny. It was really fun, and it was basically like but that's the closest we ever got to doing any real RP. So you're gonna have to educate me there one day.
Hmm.
Okay, so to get started with our class, we're going to party really hard because that's what we always do. So to get started here, what I want you to do is I want you to look at this graph here and I want you to figure out which of the following stories do you think best fits the graph. So story number one, potentially, a car is speeding up and getting faster over time. Story number two, a car is slowing down and getting slower over time. Story C, a car is driving at a constant velocity over time. And then story delta, the car is not moving at all. So you don't see the graph. That is because I am clearly incompetent. So thank you for letting me know. That's actually very helpful. There's been quite a few times this year where I would like say, look at the graph, pick an answer, and then nobody would tell me that they couldn't see the graph, and that was really awkward. Thank you for letting me know. Much appreciated. You get an A+ for that. 1,000 points of extra credit. Okay, so now you can see the graph, I believe. So I want you to look at the graph and I want you to pick which of the following stories best fits the graph. A car is speeding up and getting faster over time. The car is slowing down and getting slower over time. The car is driving at a constant velocity over time. And the car is not moving at all. As an FYI, this is a position and this is a versus time graph. So that's one thing that you should consider. Um, and I think and the graph is curved too, just in case you couldn't tell. Um, so yeah, I want you to pick one of the following best stories. A car is speeding up and getting faster over time. A car is slowing down and getting slower over time. A car is driving at a constant velocity over time, and the car is not moving at all. We have 17 people so far. We already have 13 responses. Our participation rate is off the charts right now. That's really good. Let's try to get 5 more people to respond to the warm-up question. We're at 14 out of 19 right now. 73%. Let's take another 2 or 3 more minutes to answer the question. We have a pretty strong consensus right now, which is really interesting. Um, we're at 16 out of 20. Let's get 3 more people. Question 17 out of 20. Which of the following stories best fits the graph? The car is speeding up and getting faster over time. The car is slowing down and getting slower over time. Our car is driving at a constant velocity over time, and the car is not moving at all. Also, I'm just realizing this right now. I talk pretty fast. If you ever think that I'm talking too fast, you should let me know and I'll slow down. I honestly sometimes I'm not really sure how fast I'm talking. Like I'm talking pretty fast right now. Ooh, if you just let me know that I'm talking too fast, that's very helpful. I'm a fast talker. I do everything fast. Um, 19 out of 21. I also eat really fast too. I'm one of those people who eats really way too fast, so they start choking on their food. I'm also the kind of person that's always choking on water, and then people ask me if I'm okay, and I'm like, yeah, I'm just choking on water. And so it happens all the time. So I'm one of those people who does that. Yeah, I literally inhale my food. Um, we're at 19 out of 21. Let's get two more people to answer the warm-up question, and then we will three more people. 19 out of 22. We'll take 1 more minute to answer the warm-up question. Are there any other fast eaters out there? Or does everyone eat like civilized people with their with their delicate bites and they're savoring their food? Okay, so let's move on. We are at 20 out of 23. So what we'll do today is we will look at a bunch of graphs here and we'll try to figure out what is going on in each of these graphs. Okay, so what is the answer to this? I won't give you an answer. We will actually examine the answer ourselves. Okay, so this is a position versus time graph. What do we know about position versus time graphs? Well, what we know is that the slope of such a graph, so the slope of any graph tells us the rate of change of the graph. It tells us how much the y is changing every x, right? It gives us a rate of change. In particular, the slope of a position versus time graph gives us the velocity, because the velocity is the rate of change of a position versus time graph. Right? So if we want to find the slope of a position versus time graph, right, that gives us the velocity. So that is one thing that a quick review. A second thing we want to quickly review is that when the velocity of an object is changing, that means the object has some sort of acceleration, right? It could be positive, it could be negative acceleration. It just means that there is some sort of acceleration when the velocity is changing, right? Just because it has a velocity does not mean it necessarily has an acceleration. We want to be thinking about whether or not the velocity itself is changing. So when we combine points 1 and points 2, what we get is that when the slope of a position versus time graph is changing, that object has to have some sort of acceleration. So how do we make that third conclusion? Well, the slope of a position versus time graph is the velocity. So if the slope is changing, that means the velocity has to be changing. And so if the velocity is changing, that means it has to have some sort of acceleration. So let's take a look at the graph on the right and let's take a look at the slope. So the slope at the very beginning, so the slope is again the rate of change of the graph, right? So if we were to draw a slope here, the slope here initially would be like this, and then it would be like this, and then it would be like this. So if you notice here, our slope is getting sort of bigger and bigger and bigger as the graph is occurring, right? The slope is sort of like if we drew a line like potentially parallel to the graph. So if we look at the slope of the graph, right, the slope is increasing over time. It's getting bigger and bigger and bigger, which means that the velocity of the object is also increasing with respect to time, right? So the slope here is small, and then here it's like medium, and then here it's like big. So the slope is getting bigger and bigger and bigger. So, which means that the velocity is increasing over time, which means that the object has a positive acceleration because the object's velocity is increasing over time, which means it has a positive acceleration. So what is the key takeaway from this? One, when you look at a position versus time graph, the slope of it tells us the velocity. Two, if the velocity of an object is changing, it has to have some sort of acceleration. Three, when the slope of a position versus time graph is changing, that means that the velocity is changing, which means that the object has some sort of acceleration. And so in this graph here, we can see that the slope is changing. And the reason why we know the slope is changing is because the slope is curved, right? Which means that the slope is changing over time. This means that we have to have some sort of acceleration. Okay, so how do we know if the object is speeding up or not? Good question. How do we know if the object is speeding up or not? So the better question is actually, first answer, how do we know if an object is slowing down? So the first thing we want to remember is that an object is completely stopped when its velocity is 0. If an object has 0 velocity, it is not moving, right? It's not traveling at all. So the closer the velocity is to 0, the slower it's moving, even if it's negative. And the farther away the velocity is from 0, the faster it's moving. So what does this mean? So let's take a look at this. So let's pick two velocities that are close to 0. So what I'm going to do is I'm going to pick a velocity of a positive velocity of 1 meter per second, and I'm going to pick a negative velocity of 1 meters per second. So both of these velocities are pretty small. They are pretty close to 0. One of them is moving in the positive direction. That's why it says positive 1 meters per second. The other one is moving in the negative direction, and so it says a negative 1 meters per second. They're both actually moving at the same speed, which is 1 meters per second. They're just technically moving in two different directions. One of them is moving in the positive direction, and one is moving in the negative direction. But they technically have the same speed, which is this 1 meters per second. Right? They technically are moving at the same speed, just in different directions. And so both of these are moving pretty slowly. What if your velocity is a lot bigger? Or so what if your velocity was instead 100 meters per second, and this one was a negative 100 meters per second? So notice how once again, right, there's a positive and negative, and one of them is positive 100 meters per second, and the other one is negative 100 meters per second. So they both are traveling 100 meters per second. So they both are actually moving very, very, very fast. It's just that one of them is moving in a positive direction, and the other one is moving in a negative direction. So even though one of them is very negative, negative 100, they both are moving very fast. And that's because if we just look at the raw number here, the 100, without caring whether or not it's positive or negative, this raw number essentially tells us how fast we're going. So in this case, it's telling us that we are moving 100 meters per second. But the sign next to it, the positive or negative sign, tells us which direction we are moving. So if we look here, right, the bigger the raw number is, the faster we're going. And the smaller the number is, the slower we're going, right? So if our number is very small, we're going pretty slowly. And the bigger the number is, the faster we're moving, even if it's a big negative number. And so if we are slowing down, what this means is that we're going from a big number to a small number. So we could be going from positive 100 to a positive 1, right? That's one example of slowing down, because we're going from 100 meters per second to 1 meters per second. So we slow down quite a bit. Or we could be going from negative 100 to negative 1, in which case that would also be slowing down, because we're going from a very big negative number to a very small negative number. So we're just going from going very fast in the negative direction to very slow in the negative direction. So we're essentially going from big positive to small positive, or big negative to small negative. The idea is, as the closer we're getting to 0, the closer the velocity is to 0, the slower we are going. The farther away from 0, either positive or negative, the faster it's going. So in this particular graph here, the car has a positive velocity. How do we know that the velocity is positive? Well, if we look at the position here, the position is increasing over time, which means that if our position is increasing over time, our velocity is also positive. And if we also look at the slope here, right, the slope is also positive. The velocity and the slope are positive here. So the velocity of the object is positive because the position is increasing. And we knew previously that the slope is increasing, which means it has a positive acceleration. So in this case, if it has a positive velocity and it has a positive acceleration, which means that the velocity is becoming bigger, more positive, going away from zero, this means that the car is speeding up. So we are going from a small positive to big positive. In other words, we're going away from zero, we're going away from the x-axis, which means that the car is speeding up. Things are going to get very tricky very quickly. Very tricky very quickly. The general idea is the velocity of the object, is it going away from zero or is it going towards zero? Not the position, the velocity. So we got to be looking at the slopes here. The slopes, the S-L-O-P-E-S. Looking at the slopes. All right. Okay. So here's what I want you to do. I want you to quickly either screenshot this graph or remember what this graph looks like or draw it down or take a picture of it, whatever. But I want you to burn this particular graph into your brain because I'm going to put you into your breakout groups and have you guys talk about whether or not you think the object is speeding up or slowing down. So burn this image into your brain, burn it into your brain. Remember this. What does it look like? Draw it, take a picture of it, whatever. And then whenever you have the picture burned into your brain and ready to go, I'm going to put you in your breakout groups, and then you guys are going to discuss whether or not you think it's speeding up or slowing down. Be prepared to write and share a one-sentence explanation of your analysis. I want everyone, it's okay. So what I want everyone to do is I want every person to quickly write out a 1-sentence explanation on whether or not you think it's speeding up or slowing down. So it'll take a minute or so, write out whether or not you think it's speeding up or slowing down. And then when I say enter, I'll have all of you hit enter, and then we'll read what everyone said. So write out what you and your group decided as to whether or not it's speeding up or slowing down. And then when I say enter, we'll go through and we'll read out why you think so. So is the object speeding up or slowing down? Quickly write out a quick explanation. Take 20 more seconds, write out your explanations. What did you and your group decide in terms of what the object is doing? All right, in 5 seconds, 4, 3, 2, 1. All right, hit enter, hit enter, hit enter, hit enter, hit enter. We only have 3 ideas, 4 ideas. Let's get these ideas going. Ooh, we only have 4 ideas. 27 people, 5 ideas. There we go. There you go. 5 ideas out of 27. Ooh. 6, there we go. Get these ideas going. 6. If you haven't written out, please write out what you or your group ideas were. All right, so let's take a look at this graph and let's figure out what we think the object is doing. So interesting. We have a lot of good ideas here. A lot of good ideas here. We have a lot of good ideas here. I'm looking at these ideas and I'm going to try to see if I can come up with a consensus on these. Okay, so I think one thing that everyone agrees upon is that the position is increasing the whole time. I think everyone can agree upon this, right? The position is 0 in the beginning, and then it's, I don't know, something at the end. So the position is increasing the whole time. Now, if our position is increasing the whole time, right, that means we're essentially moving forwards, right? We're moving forwards. Our velocity is positive. I think that's one thing everyone can agree upon, right? The slope is positive. The position is increasing the whole time. We're moving forwards the whole time. I think everyone can agree upon that. Now the question is the rate at which our position is increasing, is that increasing or is that decreasing? Because basically when an object is speeding up, that means we're getting, or that means we're covering more and more and more position every single second. Whereas if it's slowing down, that means every second we're not covering as much position over time. That means our velocity should be decreasing over time. So the slope is positive over time. The question is the slope increasing or is the slope decreasing? So here's the thing, right? So the slope at the very end, I think we can all agree that the slope in the beginning is pretty steep. It's moving pretty fast in the beginning. And what about the slope at the end? Well, the slope at the end, it's pretty flat. And the object, right, in the first second or so, right, it moved a lot of distance. However, in the last few seconds, right, it barely moves any distance. And the slope goes from being big to medium to small. So the slope is getting smaller the whole time. The amount of position the increasing, the amount of position that we're covering every second is getting smaller. We are still moving forward, but the amount of position we're increasing is getting smaller. So what ends up happening in this graph is that the object is actually technically slowing down. We are actually slowing down. Now, how on earth could that happen? That's really weird. Our position is increasing the whole time, right? Our velocity is positive the whole time. How are we slowing down? So here's what I want you to think about. I want you to imagine that you're in a car, you're driving, or your parents are driving, or whatever, and then you are pulling up to a stop sign. So we are pulling up to a stop sign or a red light. So what do you do when your parents are pulling up a stop, or if you're driving, your parents are driving, they hit the brakes, right? So your car is slowing down. Now, when you hit the brakes and your car is slowing down, that does not mean that you are moving backwards. It just means that the speed you're going at going forwards is going down. And eventually you stop moving altogether. Your velocity stops altogether. So in the beginning, right, we are moving pretty quickly. Then towards the middle, where we hit the brakes, so we're slowing down a little bit, our velocity is decreasing. And towards the end, we are completely stopped. So our slope is going to be pretty much zero at the point, at the end. So here we are actually slowing down in this graph. So even though we are going forward and the slope is positive the whole time, the slope is decreasing. That's the thing. We don't want to be looking at whether or not the slope is just positive or whether or not the object is going forward. We actually have to think about how is the slope changing over time, right? The position is increasing the whole time. That is correct, right? The velocity is positive the whole time. That is correct. And the question is how is our velocity changing? And for that, we actually need to look at how the slope is changing. So it's not enough to just say the velocity is positive, the position is increasing. We actually need to think about how is the slope changing. Okay. So that is the key here, right? The slope in the beginning is very big. Towards the end, it's getting smaller. And towards the end, our slope is almost zero. In a sense, our graph is almost flattening out. It's flattening out. And so when it's flattening out, it's actually slowing down. All right. So these two graphs, a little challenging. The next one, we're going to raise up the difficulty quite a bit. Quite a bit. So oh no, where did the graph go? It's so difficult, you can't even see the graph. That's how difficult it is. Okay, so once again, I want you to quickly remember, burn this brain graph into your brain, burn it into your brain, draw it down, take a screenshot, remember it, click here. And once again, in your groups, I want you to decide if the object in the graph is speeding up or if it's slowing down. And I just want you to be prepared to write and share an analysis just like last time. We actually did a really good job last time. I'm actually very proud. So let's see if we can do that again. So be prepared to do that again. So once you are ready, once you have your graph memorized or printed out or I don't know, screenshot it or taking a picture of it or drawn it out, I'm going to put you in groups again. And then I'm going to let you guys try to decide whether or not the object is speeding up or slowing down again. So what I want you to do is I want you to do the same thing as last time. I want you to quickly type out what you and your group discussed, whether or not you thought your graph was speeding, whether or not you thought the graph was speeding up or slowing down. I want you to take a minute or so to type out a response. And then when I say hit enter, I want everyone to share what you and your group said. We actually got a very good response rate last time. So I'm actually very happy about that. Let's see if we can continue the good work. And yeah. So it'll take a minute or so. So at around 10:52, 10:52 and a half, way to hit enter. All right, let's take another 20 seconds or so. All right, 4, 3, 2, 1. Let's go, 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 go. Oh my God, we have so many responses here. Oh my God, I can't even read them all. Let's keep going. Oh, just keep, we're going, we're going. Keep hitting enter. Keep typing out your responses. Keep hitting enter. We already have like 1, 2, 3, 4, 5, 6. We already have 7, 8, 8. That 8's really good, but I know we got more last time. Can we get more? I'm trying to type in responses. Slowing down, braking quickly, then moving slowly, reversing and slowing down, and stopping at the end. I'm slowing down, you can see that I'm flattening out. You go, then stop, and the difference this time is going opposite. Ah, interesting. Slowing down because the slope is becoming more horizontal, which means the rate of change is slowing down. Okay. All right. All right. So let's take a look at this. Take a look at this. So first off, what is the object doing? So first off, the position is decreasing the whole time. Which means that we are moving backwards. Which means that our velocity is negative. However, the slope is essentially decreasing. It's flattening out, right? So initially, our slope is it goes from being pretty steep to being pretty flat. Right. So initially the velocity is very negative, and as time goes on, right, the slope becomes less. It decreases. It starts becoming less and less steep, and eventually at the end it becomes basically horizontal. When your slope is horizontal, it means that it basically means that you're not moving very fast. If you're moving at all. So what I really like what we notice here, I really liked how we noticed a lot. What I really think was really interesting, really liked how we all were looking at the slope. And we were all looking at how the slope was changing as time occurred. I think that's really interesting. I think that's really, really cool. And I like how we all noticed the slope was becoming more and more flat as time went on. And so that sort of signified that the car was slowing down. Really interesting. Yeah, so this is, once again, the object is slowing down again. Really interesting. So we're gonna look at one more graph here. Same process, same idea. You might have even be able to guess what this graph should look like. We got one more. So Within your groups again, I want you to quickly remember to burn this graph into your brain. Take a picture of it, write it, draw it out, whatever. Um, be prepared to share an explanation of it. And then I want you to know within your groups, I want you to decide whether or not the object in this graph is speeding up or if it's slowing down. Whenever you are ready, whenever you have the graph sort of recorded, I'm going to open group breakout groups, and then you can join your group again and decide if it's speeding up or if it's slowing down. All right, so let's talk about this graph here. I actually heard some really good analysis here. So I'm actually going to try to share some of their ideas here. So here's one thing that I think is really interesting. So first off, the initial graph here, on the one on the right, your position is decreasing over time, which tells us that our velocity is negative. Does that mean we are slowing down? No, it does not mean that we are slowing down. We are moving backwards. But we need to figure out, are we moving backwards faster or are we moving backwards slower, right? So there's a difference. Slowing down does not mean moving backwards, right? Slowing down just means how fast are you moving backwards or how slow are we moving backwards, right? So that's what we got to think about. We know from the graph that our velocity is negative. Now we got to figure out, is it going faster negative or is it becoming slower negative? So initially, right, in the first second or so, we are not moving that much, right? Our position did not change that much in the first second or so. We really didn't move that much. So we are moving backwards. Our position is decreasing just by not that much. Our rate of change is very small. Then a few seconds later, our rate of change gets a lot bigger, right? We are starting to cover a lot more position over time. And towards the end, we are really starting to cover a lot of position every second. So even though we are moving backwards at a faster and faster rate. We are going backwards faster and faster and faster. And so even though we are moving backwards, we are actually speeding up in this graph, which I think is really interesting. It's a good thing to think about. Okay. So does anyone have any questions about these graphs before we move on? Okay. So for the rest of today, we are going to start our next assignment here. The next assignment is called the position and velocity graphs. I'm setting this as a due for next Monday, Tuesday. I may push this back one more day, but we'll see. So we're going to spend the rest of the class today getting started with this. The first question will look very similar to what we just did. So I just want you to quickly work through that. So yeah, get started with the assignment and we'll spend the rest of the period working on this. Additionally, if you are interested, a student reached out to me and their club, the Wombats Club, is hosting a rocket scientist from the Jet Propulsion Lab this Friday from 2 to 3 p.m. The Zoom link for the club is as followed. I will also post an announcement on Canvas for this as well. But if you're interested, please check it out if you're interested. Other than that, just get started with the assignment. I know we only have 15 minutes left, so I know you may be tempted to not do anything. However, again, I would always recommend getting as much done in class as possible, especially since I can answer your questions in class. So let's try to get as much work done in the last 15 minutes or so. And then, yeah. Once again, the assignment is posted on Canvas. I also linked it in the chat again. Okay, it's 11:20, so I got to bring everyone back. Okay, so in terms of your homework, we'll keep working on this on Friday, so you don't need to do anything over the next few days. I would say make sure you finish any unfinished assignments or you revise anything that you need to revise. You can and should revise any assignments that you don't feel like you want. You feel like you if you feel like you could do better on assignment, you should definitely revise them. The quarter ends, I believe, this Friday, I believe. So quarter grades will be coming out very soon. I'm pretty caught up with grading. I still have a fiscal one assignment that I haven't really fully graded yet. But everything else, I'm pretty up to date. So keep revising stuff and keep submitting stuff and for your grades before the quarter deadline. Other than that, that should be it. And I will see you guys on Friday.
Thank you.
Thank you.
Thank you.